On the night of July 1st, 2025, at a survey station in Rio Hurtado, Chile, a telescope camera captured a faint point of light crawling across the sky at a speed that made no sense. Within 72 hours, astronomers across 3 continents had confirmed the impossible. This object was not orbiting our sun. It had come from somewhere else entirely, outside our solar system, moving so fast that nothing here could ever hope to hold on to it. Then came the second shock. When researchers dug back through archived images from telescopes around the world, they found the object hiding in pictures taken weeks before anyone noticed it, frames stretching all the way back to mid-June of 2025. It had been sitting there in plain sight and nobody knew. Now imagine being one of the astronomers, staring at that old data, realizing you were looking at something that might be older than the sun itself. Not older by a few million years, possibly older by billions. Stay with me, because what scientists eventually confirmed about this object is one of the strangest, most quietly explosive space stories in years, and most people online still have the basic facts wrong. If you want the real data instead of the noise, follow this channel now, because we're about to walk through exactly what happened. Let us start with the basics in plain, simple terms. Our solar system has one sun, 8 planets, dozens of moons, and countless smaller bodies like asteroids and comets, all of them bound by the sun's gravity, all of them looping around on paths that repeat forever. Everything that belongs here gets pulled back again and again, locked into an endless orbit like a runner on a circular track who can never leave the lane. But every so often, something arrives that does not belong here at all, something that formed around a completely different star, somewhere out in the wider galaxy, and is only passing through our neighborhood once before leaving forever and never coming back. Astronomers call these rare visitors interstellar objects, and in the entire span of recorded human history, we have only confirmed 3 of them. Think about that for a second. Thousands of years of humans staring up at the sky, building telescopes that grew sharper and sharper, launching satellites that could see in the dark, and in all that time, only 3 confirmed pieces of alien star systems have ever swung close enough for us to notice. 3. That is how vast and how empty the galaxy really is, and how rare a moment like this one truly is. To see even one of these visitors requires a kind of luck that involves ancient timing, patient engineering, and being alive at exactly the right window of human history. The first one showed up in 2017. It was small, strangely elongated, and tumbled through space in a way nobody had seen before, which made headlines for years. It looked almost nothing like the familiar comets you see in textbooks, no obvious tail streaming behind it, no glowing dust cloud, no dramatic signs of activity. Just a faint smudge moving strangely against the static stars. And by the time telescopes were fully trained on it, it was already too faint and too far away to study properly. Scientists scrambled. They pulled every instrument they had into position. But the visitor was already on its way out the door, slipping back into the dark where no telescope could follow. It left more questions than answers, and parts of its behavior are still debated today simply because there was not enough time to gather the data. Imagine meeting someone fascinating at a party, getting only 2 minutes to talk, and then watching them walk out the door forever. That is what that first encounter felt like. The unease afterward was not just frustration. It was the awareness that we had been handed a clue from another star system and dropped half of it on the floor before realizing what we were holding. The second interstellar object arrived roughly 2 years later in 2019. This one behaved much more like a familiar comet, glowing brighter, trailing a visible tail of gas and dust, which let scientists collect a richer set of chemical data than they had managed with the first visitor. They got spectra, they got colors, they got measurements of the kinds of molecules boiling off its surface. Even so, the timing was still painfully short. The instruments were pointed, the readings were taken, but the visitor was already fading back into deep space. Both of those early encounters left scientists hungry for a third chance, a bigger, brighter, more active interstellar visitor that would give the world's best instruments, including tools that did not even exist back in 2017, enough warning time for a proper, detailed look. Something they could study while it was still close, something they could watch wake up, light up, and then drift away, carrying all of its secrets on a schedule humans could plan around. That third chance arrived on July 1st, 2025, when the asteroid Terrestrial Impact Last Alert System, known as ATLAS, a network of telescopes built specifically to scan the sky every clear night for anything that could threaten Earth, flagged a fast-moving point of light. The system was not even hunting for aliens. It was hunting for killer asteroids. Yet the same cameras, the same algorithms, the same patient nightly sweep of the sky caught something far more exotic than a rock on a collision course. Astronomers checked its trajectory, and within days they had their answer. This object was moving far too quickly to ever be captured by the sun's gravity. It was not going to loop back around like a normal comet. It was not going to swing past Mars, then Jupiter, then come home again millions of years from now. It was going to sweep through our neighborhood and keep going, out into deep space forever, with a velocity that left no doubt it did not belong here. This was the third confirmed interstellar object in recorded history, and it was named 3IATLAS, the number 3 marking it as the third of its kind, an atlas honoring the survey system that caught it. Once astronomers knew what to look for, they went back through older archives, the kind of digital attic where every image ever taken by every telescope is quietly filed away. They found pre-discovery images of the comet dating back to mid-June of 2025, and later still to mid-May of 2025, with the earliest confirmed detections now stretching back to May 7th of 2025. The object had been hiding quietly in the data the entire time, sitting in plain sight like a clue on a wall that nobody had thought to look at. Right away, something about this visitor stood out. Its orbital path was the most extreme, most sharply bent hyperbolic trajectory ever measured for an interstellar object, with an eccentricity so high it dwarfed both previous visitors combined. In simple terms, the shape of an object's path tells you how strongly it is or is not attached to the sun's gravity. A path that curves gently and loops back, like a soft smile drawn on paper, is something that belongs here, something the sun holds in a soft grip forever. A path that comes in fast, bends only slightly, and shoots straight back out like a near straight line with the faintest curve, is something the sun barely touched, something only passing through. And 3IATLAS had the sharpest one on record. Its path was so straight that the sun's gravity barely left a fingerprint on it. It was also moving on a retrograde path, tilted more than 170 degrees relative to the plane where the planets orbit, meaning it was essentially cutting through the solar system almost backward compared to everything else out there. You can picture this in your head. Imagine a giant flat dinner plate representing the orbits of all the planets, all circling the sun in the same direction like hands on a clock. Now imagine a dinner guest walking onto the table from below, crossing the plate almost straight up, almost the opposite direction of everyone else. That is what 3IATLAS looked like. Its path did not politely join the local traffic. It cut across it like a stranger walking the wrong way down a one-way street. At discovery, it was already moving well over 200,000 kilometers an hour, and it only accelerated as it fell closer to the sun, eventually reaching speeds above 60 kilometers per second at its closest approach. That kind of speed is hard to imagine in human terms. A rifle bullet, slow. A jet airliner, slow. The International Space Station orbiting overhead every 90 minutes at nearly 30,000 kilometers an hour, still slow. This thing was moving faster than almost anything we have ever watched cross our sky. And the closer it fell toward the sun, the faster it moved, because gravity just kept pulling harder, accelerating it, the way a ball rolling downhill only picks up speed. Imagine throwing a ball straight down a hill and how it does not glide gently along. It just keeps gaining speed the longer it rolls. The sun is the hill, and 3IATLAS is the ball that never loses momentum. Here is where the story gets genuinely shocking. And it is the reason the story opens with a line about the sun. Based on how fast this object is moving relative to the average motion of stars in this part of the galaxy, scientists estimated roughly how long it had been drifting through interstellar space since it was first flung out of whatever star system built it. To put it simply, when you watch how fast a wandering rock is moving compared to the average drift of the stars around it, you can do a kind of galactic archaeology. You can roughly backtrack how long it must have been out there. Their estimate placed its age somewhere between 3 billion and as much as 11, and in some more recent modeling, potentially up to 12 billion years old. For comparison, our own sun and our own solar system are about 4.5 billion years old. That means this comet is not just possibly older than the sun. It could be more than double the sun's age, a frozen relic that started forming when the universe itself was still young, drifting alone through the galaxy for that entire stretch of time, completely untouched, until it happened to cross paths with us. Think about what that means. Imagine a chunk of ice that has been wandering in the black, with no sun to warm it, no planet to land on, no noise, no light, just endless quiet, for billions of years longer than the entire history of life on Earth. Dinosaurs rose and fell, mammals took over, humans built cities, launched rockets, and pointed telescopes at the sky, and through every single one of those moments this piece of ice just kept drifting. It did not know we were here. It did not care. It just kept tumbling through the silence. Then, by pure chance, it tumbles into our part of the galaxy at exactly the moment we happen to have telescopes strong enough to see it. The timing feels almost too perfect to be coincidence. The universe handed us a visitor older than our own star, and we happen to have the right tools ready in time. If our space telescopes had not been built yet, if the survey cameras had not been pointed at that patch of sky, if one of the astronomers had not taken an extra look at a faint smudge on a Tuesday night in Chile, we would have missed it forever. The fragility of that timing is hard to overstate. If that alone does not stop you for a second, nothing will. A piece of another solar system, quite possibly the oldest comet ever directly studied by humanity, drifted close enough for our best telescopes to actually get a look. And unlike the first interstellar visitor, which looked mostly quiet and rocky, 3IATLAS turned out to be a genuinely active comet. As it approached the sun, frozen material on its surface began turning directly into gas, streaming away and forming a glowing cloud called a coma, along with a visible tail trailing behind it like hair in the wind. This mattered enormously to scientists because an active object releases its internal chemistry into space, where instruments can actually detect and analyze it. A quiet, frozen rock keeps its secrets locked inside. An active outgassing comet hands them over. It is the difference between a sealed letter you cannot open and an envelope that has already been torn open, with the contents drifting into the room for everyone to read. Now it is worth appreciating just how much coordinated effort went into catching this object in the first place. The survey network that found it scans huge portions of the night sky over and over, comparing each new image against the one from the night before, looking for anything that moved. Almost everything it catches is an ordinary asteroid safely orbiting within our solar system, because the system exists mainly to spot potentially dangerous rocks early enough to calculate whether they threaten Earth. The night sky is a noisy place. Every clear night, the survey cameras collect millions of stars, hundreds of variable blips, satellites passing overhead, cosmic rays, weather artifacts, glitches, software bugs. Almost every moving dot they flag turns out to be something mundane. Catching a genuine interstellar object at all is an enormous bonus, a needle in an almost unimaginably large haystack of nightly sky images. But here is the gift that came with the catch. Because the system caught 3IATLAS with months of advance warning before its closest pass by the sun, scientists finally had something they never really had with the first two visitors: real lead time. That lead time meant space agencies could schedule some of the most in-demand telescopes in the world well ahead of time, instead of scrambling at the last second the way teams had to back in 2017. Imagine being given months of warning about a famous guest visiting your city instead of getting 2 minutes notice that they are already in your driveway. That difference in lead time can make the difference between a chaotic, blurry snapshot and a careful, layered portrait. The astronomers involved compared it almost to having time to set up a studio, light the room, aim multiple cameras, and wait for the perfect moment. That luxury, after years of frantic catches, was itself a milestone. Once the object's interstellar origin was locked in, observatories across the globe, along with space telescopes far above Earth's atmosphere, lined up to take their turn. The James Webb Space Telescope, often just called JWST or Webb, is the most powerful space telescope humanity has ever built. It does not see light the way our eyes do. Instead, it is tuned to detect infrared light, longer wavelengths that carry heat signatures and chemical fingerprints invisible to ordinary telescopes, which makes it perfect for reading the exact chemical makeup of faint, distant objects. Picture it as a telescope that does not just look at the colors of things, but sniffs them the way a dog sniffs footprints. Each molecule of gas leaves its own unique signature in infrared light, like a fingerprint, and Webb can read those fingerprints from hundreds of millions of kilometers away. This is why infrared is so useful for comets. The gases they release are often cold and faint in visible light, but glow brightly in the longer infrared wavelengths Webb was designed to capture. Webb was never designed with fast-moving small solar system objects in mind, and tracking something moving as quickly as 3IATLAS across the sky pushed its systems in ways engineers never fully planned for. The telescope usually stares at distant galaxies that barely move in human terms. Pointing it at something streaking across the sky at over 200,000 kilometers an hour is like asking a camera built for portraits to suddenly track a hummingbird. Despite that, they managed to lock Webb onto the comet in August of 2025, capturing its first detailed spectrum, essentially a chemical fingerprint written in light. After the comet swept around the sun and began heading back out, Webb observed it again in mid-December of 2025 with a different instrument tuned to mid-infrared wavelengths, capturing the most detailed chemical readout ever taken of an interstellar object. 2 passes, 2 instruments, 1 visitor, a quiet kind of choreography between human engineering and alien material. What came back from those readings then surprised a lot of scientists. The comet's chemistry did not match the expected pattern from comets that formed here in our own solar system. For one, it showed an unusually high amount of carbon dioxide compared to water vapor, a ratio that stood well outside the norm. According to the study, eventually published in the journal Nature on June 22nd of 2026, led by researchers at NASA Goddard using Webb's NIRSpec instrument, the comet's methane-to-water ratio measured roughly 11 times higher than any solar system comet ever recorded. Alongside the methane and carbon dioxide, Webb also picked up clear water vapor and a very specific atomic signature belonging to nickel, an unusual find that hints at the raw ingredients mixed into this object when it first formed, likely billions of years ago, around a star that may not even exist anymore. The star itself might be long dead, swallowed up by a supernova, or faded into a quiet dwarf, while a chunk of its old cometary family kept drifting outward forever. The fact that we can hold a piece of that vanished world in a spectrograph here on Earth feels almost absurd. It is a kind of science that would have felt like fantasy a generation ago, and yet here it is, sitting in a published paper. To understand why the methane mattered so much, it helps to know what methane actually is: an extremely simple, lightweight, fragile molecule that tends to break down under the raw cosmic radiation. An object drifting alone through interstellar space for billions of years would be bombarded with constantly. Picture a sheet of white paper left out in the sun for decades. It does not stay white. It yellows. It crumbles. Methane in space behaves similarly. Radiation strips it apart over time. Scientists did not expect to find much of it left on the outer surface of an object this old. So finding a strong, clear signal coming off the comet forced researchers to think carefully about where it was actually coming from. The leading explanation is that the outer layers lost most of their original methane over billions of years of radiation exposure, and what Webb detected was methane escaping from deeper, unprocessed material underneath, shielded the entire time and only now being exposed as the comet's outer layers boiled away in the heat of our sun. It is like an ancient frozen meal buried deep in permafrost, slowly being cooked for the first time since it was frozen. In other words, Webb was reading material locked away, untouched since before our own solar system existed. That single detail alone is enough to give an astronomer chills. We were tasting, in a sense, the chemistry of a star that died before our sun was even born. The chemical surprises did not stop there. In 2026, a separate team using the European Southern Observatory's Very Large Telescope in Chile, led by astronomer Cyril Opetom, measured the ratios of specific carbon and nitrogen isotopes locked inside the comet's gas and found the ratio of carbon-12 to carbon-13 was higher than anything measured in solar system comets or the surrounding interstellar medium itself. Deuterium, a heavier version of hydrogen that scientists use like a fingerprint to trace where a comet was born, was also detected at unusually high levels, far above what we see in comets that formed right here in our own neighborhood. NASA's Hubble Space Telescope observed 3IATLAS, both shortly after discovery and again after its closest approach to the Sun, giving scientists their first estimate of the size of the comet's solid nucleus buried underneath all that glowing gas and dust. Measuring that size proved genuinely tricky, since the tiny solid core is almost always drowned out by the much brighter cloud surrounding it, and estimates shifted as more data came in, ranging from under 1 kilometer, based on how the comet behaved non-gravitationally up to 5 or 6 kilometers across in broader Hubble-based models. Either way, this made it noticeably larger and more active than either of the two interstellar objects discovered before it, part of why it became so much brighter and easier to study in detail. Think of trying to guess the size of a walnut hidden inside a glowing cloud of steam. You have to look around the steam, follow the way the dust moves, watch how sunlight scatters off it, and slowly close in on the truth. Other instruments joined in too. A space telescope called Sphere-X, built to survey the entire sky in infrared light, took its own look in December of 2025 and picked up signs of increasing activity after the comet's closest solar pass, along with tougher, heat-resistant dust mixed into the coma. Ground-based radio telescope arrays also chipped in, detecting molecules like methanol and hydrogen cyanide escaping from the comet. Each new molecule added another line to a kind of cosmic recipe card, listing what this object was made of and what it had been through. NASA's Mars-orbiting MAVEN spacecraft even imaged the cloud of hydrogen atoms surrounding it as it passed roughly 1.8 astronomical units from Earth at closest approach, about 270 million kilometers away, well inside the orbit of Mars, during its October 30th, 2025 pass by the Sun. That distance might sound enormous by human standards, but in the scale of the solar system, it is practically next door. We had front row seats. That kind of curiosity is a normal human reaction. And rather than dismissing it, scientists actually went and checked. Researchers with the SETI Institute and Breakthrough Listen pointed the Allen telescope array directly at 3IATLAS and sifted through close to 74 million individual radio signals looking for anything artificial. A little over 200 survived initial filtering, and every single one was traced back to ordinary human-made interference, satellites, and terrestrial equipment. Nothing extraordinary. No artificial signal of any kind was ever detected. Every piece of data collected, from Webb's chemical fingerprint to Hubble's imaging to the isotope studies to the radio searches, points to exactly what an ancient natural comet should look like. This is a real ancient piece of another solar system, not anything built or artificial, and the verified science here is already wild enough without needing to add anything to it. There is a quiet relief in that. We do not need to invent mystery. The real chemistry of this object is stranger than any story we could make up. So, what does all of this actually mean going forward? And why should it matter to someone who is not an astronomer? For one, every interstellar object scientists get the chance to study, up close hands them, a genuine physical sample of material built somewhere else entirely, around a star system we will likely never visit or directly see in detail. The galaxy is huge. Crossing it is impossible with current technology. But every now and then, a piece of another world comes to us, drifting in on its own for free, no spacecraft required. That is a kind of delivery service no mission could ever replicate, and the cost is simply the patience to wait and the cleverness to spot the visitor when it arrives. There is also a bigger scientific picture forming here. Each interstellar object detected adds to our understanding of how common these wandering objects actually are throughout the galaxy. For a long time, scientists debated whether interstellar visitors were incredibly rare, one-off events, or whether space is actually full of them, quietly drifting past us undetected simply because the tools and the time were never good enough to catch them. The fact that 3 of these objects have now been confirmed within less than a decade, with detection technology improving every year, suggests these visitors might be far more common than anyone originally guessed. As newer, more powerful sky survey telescopes come online in the coming years, scientists expect the detection rate of interstellar objects to climb significantly. In other words, 3IATLAS may not be some rare, once-in-a-lifetime event. It might just be the 3rd confirmed sighting in what could become a fairly regular stream of ancient visitors passing quietly through our neighborhood, most of which we simply have not had the tools to catch until now. That thought alone should change how you look up at the night sky. Out there right now, more pieces of other solar systems are likely drifting through our own, ancient, frozen, and completely unnoticed, waiting for the next telescope powerful enough and lucky enough to catch sight of them before they slip back into the dark. There is also a very practical reason astronomers are eager to build better detection systems going forward. A brand new ground-based survey telescope, purpose-built to scan the entire visible sky every few nights with extraordinary sensitivity, recently began full operations, and many scientists expect it to dramatically increase how quickly future interstellar objects get identified after entering our solar system. More warning time means more opportunities to line up telescopes like Webb and Hubble well in advance, the same way astronomers managed to do with 3IATLAS instead of racing against the clock the way teams had to with the very first interstellar visitor back in 2017. Every improvement in detection technology translates directly into richer, more detailed science the next time one of these ancient wanderers passes through. It is also worth remembering how much combined global effort went into understanding this one comet. The initial detection came from a ground-based survey network in Chile. Confirmation and orbit calculations involved observatories across multiple continents comparing notes within days, and space telescopes operated by different national space agencies took turns studying it from orbit, each contributing a different piece of the chemical puzzle. Teams at NASA Goddard, the European Southern Observatory, and the University of Edinburgh all published findings within weeks of each other in 2026, converging independently on the same conclusion about the comet's ancient alien chemistry. It is a quiet but genuinely impressive example of global scientific cooperation working toward one shared goal, understanding this visitor as completely as possible before it disappeared for good. Somewhere in that data, future historians of science may look back on this object as the moment we realize that pieces of other worlds are not just science fiction curiosities, but real, measurable, repeatable phenomena. We can actually begin to inventory. At some point in its ancient history, gravitational interactions, perhaps a close encounter with a passing star, flung it out of that system entirely, sending it drifting alone through the emptiness of interstellar space with no star to orbit, no light to warm it, just endless cold and silence. For possibly billions of years it drifted like that, tumbling through the space between stars, completely untouched, carrying its original chemistry locked away and frozen. Then purely by chance, its long silent journey brought it close enough to our sun that our solar system's gravity could finally bend its path, and our telescopes could finally catch sight of it. It swept past the sun, warmed up just enough to release some of that ancient frozen material into space, giving instruments a brief window to study it, and then it continued on its way, heading back out into the depths of the galaxy, likely never to return, possibly never to be seen by anyone again. A few hundred years earlier, it would have simply been an unexplained, blurry point of light in the sky, if anyone had noticed it at all. We happened to be alive with the right telescopes pointed at the right patch of sky during the one brief moment this ancient traveler passed close enough to notice. That is an extraordinary stroke of cosmic timing, and it took enormous coordinated effort across multiple space telescopes and observatories worldwide to make the most of that narrow window before the comet faded from view for good. Scientists are still analyzing the data collected from 3IATLAS, and more detailed findings are expected to keep emerging as researchers dig deeper into everything Webb, Hubble, Sphere-X, the Very Large Telescope, and every other instrument managed to capture. The findings from this comet have already been formally published across multiple leading scientific journals, confirming its ancient cold origins and cementing its place as the most thoroughly studied interstellar object humanity has ever encountered. Every new detail adds another small piece to a much bigger puzzle about how solar systems form, how common interstellar wanderers really are, and what other star systems out there in the galaxy might actually be made of. To wrap this up simply, in the summer of 2025, a fast-moving object was spotted heading through our solar system, and within days, scientists confirmed it was not from around here at all. It was the third confirmed interstellar object in recorded history, and it turned out to be one of the most extreme ones ever measured, moving on the sharpest, most hyperbolic, most steeply tilted path scientists had ever tracked. The James Webb Space Telescope captured detailed chemical readings showing unusually high carbon dioxide, the first ever direct detection of methane from an interstellar object at levels roughly 11 times higher than any solar system comet, clear water vapor, and a rare atomic signal from nickel. Follow-up studies using the Very Large Telescope measured unusual carbon and nitrogen isotope ratios and an elevated deuterium signature nearly 30 times higher than typical solar system comets, pointing toward an origin in the cold, isolated outskirts of a star system far older than our own. Hubble helped to pin down its size. Sphere-X and ground-based radio arrays added even more chemical detail, and a dedicated search across nearly 74 million radio signals for anything artificial came back completely clear, confirming this is exactly what it appears to be, a genuine, natural, ancient piece of another solar system passing quietly through our own before heading back out into deep space, likely never to return. That is the real story, backed by real data from real telescopes, gathered by real scientists working across the globe to make sense of one extraordinary visitor. And it is stories like this, grounded entirely in verified science, that this channel exists to bring you first. Follow now if you have not already. Drop a comment telling us what surprised you most and share this with someone who would find it as fascinating as you do. See you in the next one.